So in this fourth module of our Azure networking course, we're going to take a look at some of the services that are available in Azure to help supplement your overall network configuration. So we know we've got subnets, VNets, we've got rules, we've got IP addresses, but what are some of the higher level application services that are available to kind of round out our overall networking implementation? Well, the first one that we're going to take a look at is something called Azure DNS. Now, Azure DNS is a managed DNS service that exists within Azure that you can use to create and manage DNS zones. If you've ever gone to an ISP and bought a web domain, they've typically given you some sort of browser-based ability to manage your DNS records. That is exactly what this is. You can create an Azure-based DNS service to manage your records within the Azure platform. Now, there's several reasons you might want to do this. And the simplest of them is if you have public name resolution, it keeps everything confined within one set of tools. So you can use PowerShell, ARM, and all your Azure tools to manage your DNS as well. There's several types of records that are available within Azure DNS. We have traditional host records. We have your traditional CNAME or canonical name records, which are just other names for existing services. We have MX records that are used for email. So when you sit at contoso.com, it's looking for the MX record for contoso.com to find out where to route email. We have name server records to delegate DNS zones. We have start of authority records, service records that are used by many services like, for example, Exchange, Active Directory, and so on. And then finally, text records, which have various uses in DNS, everything from storing random config information to proving you own a particular zone for the purpose of validation. These are the types of records that Azure DNS supports. When you create an Azure DNS record, it looks something like this. You can create any domain that you want within Azure DNS, providing that domain is not already resolvable somewhere on the internet, providing someone doesn't already own that domain. Once you create that zone, Azure will tell you the name server records that you can use to delegate control of that zone to your Azure DNS implementation. So let's say, for example, I buy a domain from Network Solutions. I did this not too long ago. So I buy a domain, let's call it, Corey'sAzureClass.com. I would simply register that, create a DNS zone in Azure, Corey'sAzureClass.com, go on to Network Solutions, and input the name server records that you can see Azure providing me as a way of delegating control of that public DNS name to my Azure DNS implementation. Now I can come in via the Azure portal, just like I'm managing my VMs and my storage and everything else, and manage all my DNS records. I mentioned one of the benefits of this is you can now manage it using all the same tools you use for Azure. Here's a sampling of the Azure DNS PowerShell commandlets. So subscription, resource group, and then creating a new DNS zone. Simply new Azure RM DNS zone. Getting the start of authority records. And then creating just a simple www record for a website. So you now have full control over DNS in the same way you have control over every other element within Azure. So that's fine. Let's go take a look at this in action. Let's take a look at how we manage DNS using the Azure DNS function. So I've got an empty resource group which I've called Azure DNS East, and we're going to add a new DNS server to this resource group. So I type DNS, and we want an Azure DNS zone. Now what this will let us do is have an authoritative zone within Azure that we can use to manage DNS in much the same way you would manage it with any name server DNS provider. So we're going to give a zone name. Now this is a DNS name we'll want to obviously already own. Maybe we've bought this from a network provider like Network Solutions or someone else. But for now, I'm just going to make up a name. Call it CoreyHeinzOnline.com. Choose my resource group and subscription and go ahead and click Create. Now, it doesn't take very long to create this zone. It'll be created in just a minute or so, and we'll be able to go in and do some administration on that zone. So hit refresh here, and so there we go. My zone is created. Go ahead and click on my zone, and now you're in what should be a relatively familiar place. This is a DNS record editor. It's going to give you the pertinent information up top. These are the authoritative DNS name servers that have a copy of your zone. So, for example, if you had bought this zone from Network Solutions, you would delegate authority of that zone to one of these name servers to make your name fully resolvable on the internet. Records are easy to manage. We'll simply click Add a new record set. And we're going to add a host record. Call this one Web Server. We can choose the type, and all the common DNS record types are supported. We're going to do an A record, our TTL, and then the IP address. Now, DNS doesn't validate IPs. We're just going to make up an IP address and click OK. Now, if I add more than one IP address, it'll do DNS round robin. So I've now got a DNS zone, and I've added a simple host record of 1.1.1.1 for the IP address webserver.coreyhinesonline.com. We're going to go and validate that that zone is now active and this DNS function is actually doing what it's supposed to do. And for that, we're going to use PowerShell. And we're going to use the equivalent of an NS lookup in PowerShell, which is resolve DNS name. The name we want to resolve now, if I simply run this command, it's going to fail because I haven't, number one, I don't own the domain CoreyHinesOnline.com. And even if I did own it, I haven't actually gone to a name server registrar and delegated control of that zone to these Azure DNS servers. But the data does exist. So we're just going to tell this PowerShell command which DNS server to actually pull the data from, or which DNS server to query. NS1, NS1-04.azuredns.com. And that should have worked. Oh, there we go. Let's just correct our DNS server name, NS1-04. And we can see it's now queried that DNS server and pull back the correct IP address. Deleting a DNS record is as simple as highlighting it and pressing delete. And we can now use this both via the portal and also via PowerShell to add, modify, remove DNS records, and certainly simplifies the use of DNS within Azure. The next set of application or networking services that we're going to take a look at revolve around how we distribute network traffic in Azure. Now, if we think about, how we might deploy something in Azure, this is what a typical application might look like. So what I've got here is I've got a let's clean this up. So what I've got here is let's say a fairly distributed Azure application. So I've got a subscription. In my Azure subscription, maybe I have an application that's a multi-tier database application. So I've got a scale set consisting of a bunch of web servers that all talk through assorted things to a back-end database here. And maybe over here, in another Azure region, maybe this is, this is East US over here. Maybe this is Australia down here, because I service two areas of the world. And then I've got the exact same setup. I've got an identical scale set that I built off a template talking to a back-end database. How do I ensure that, as my user is sitting down here on their little laptops, there's my user and he's sitting on his laptop browsing the web, how do I ensure that he, number one, goes to the closest instance of my application, and number two, that I'm equally balancing across all the copies of my application that are running in the subscription, and that if one of them fails, I take that failed one out of service without, drastically affecting the application. That's where tools like Azure Network Load Balancing, Azure Traffic Manager, and Azure Application Gateway begin to factor into the picture. Network Load Balancer works kind of at a smaller level to load balance across multiple instances of an application within the same VNet, within the same subscription. Azure Application Gateway works in much the same way, but kind of at a different protocol level. We'll talk about the difference in a few minutes. Azure Traffic Manager works to route traffic between two separate implementations of my application, maybe across two distributed parts of the world. So ultimately, balancing and distributing my network traffic is using a combination of all of these technologies effectively. Everything from Traffic Manager to load balancing to Application Gateway. So to begin with this, let's take a look at Azure. Let's kind of compare the two here, compare the three of them here. The technology for Traffic Manager is based on DNS. So it's simply using DNS queries to work out where you should go. The Application Gateway is a layer 7 load balancer. The load balancer is a layer 4 being, they're talking here about the OSI model. Let's grab my pen. So they're talking about, when we talk about layer 7, layer 4, what they're talking about is the oops. There we go. Traditional OSI model. Layer 7 being the application layer, layer 4 being whether it's basically at the TCP level, so port and protocol level. So for example, I could load balance FTP traffic with a load balancer, but not necessarily with an application gateway. With an application gateway, it's limited to HTTP and HTTPS. The endpoints can be any Azure IP address for an application gateway. And then for the Traffic Manager, it's any external endpoint. So the Traffic Manager is the bigger of the two. It's designed to work at a broader scale and distribute load across geographic regions, subscriptions, or different Azure data centers. The endpoint mapping is through something called a probe. And a probe is something that you're going to set up as part of establishing a load balancer or a gateway. And the probe's job is to essentially connect to a port and make sure it's active. And if the port's not active, it takes that particular node offline. So if we've got a number of nodes behind a load balancer, it'll check each one with a probe. If one of them doesn't respond, it considers that one offline and takes it out of service. With Traffic Manager, because it's limited to HTTP, it's just going to do web queries. And if a web query fails, it'll take that entire region offline. So what can we do with a load balancer? There's 4 major use cases for a load balancer. Incoming traffic from the internet. So if you have 2 web servers, this is the simplest implementation, 2 web servers, and you want to make sure it balances the traffic across both, a load balancer will do that. It can balance them between VMs in a VNet, so on an internal side. If I have, for example, multiple SQL servers and I want to balance those SQL servers as part of my application, a load balancer can do that. It can also forward traffic to a specific VM. So in addition to load balancing, you can say that, hey, if I SSL to a particular port number, always go to a particular VM. And when we look at an example of a load balancer, you'll see that one of the things you'll commonly do is create a rule which load balances, but maybe you want to forcibly hit a particular node for diagnostics purposes. You can create rules in a load balancer to make sure that inbound traffic goes to a particular node based on how the traffic is coming in. And the most common way being with a port number. And you have the same traditional ways of configuring this, the portal, PowerShell, the client, or with ARM templates. What are the requirements for a load balancer? You obviously need a front-end IP configuration, a public IP or a private IP. You need a back-end address pool. So where is the back-end traffic going to go? It's going to come into one IP address, and then it's going to go out, load balance to multiple IP addresses. You need rules for load balancing, which ports get load balanced and which do not. You need probes, which we briefly talked about. And you also need inbound NAT rules. A load balancing rule distributes the traffic. A NAT rule sends the traffic to a specific instance behind the load balancer. So that sounds like a lot. It's really not that complicated. And so we're going to go ahead and deploy a load balancer, just kind of explore it a little bit, and you'll get an idea of how this works and how it's configured. Here we'll take a look at how to deploy a network load balancer within Windows Azure. Now to begin, I've got a resource group, and let's kind of walk through what's in this resource group as a point of getting started. So to begin, I have an availability set. If you're going to do load balancing, the virtual machines that you load balance have to be a member of an availability set, and you got to remember that you set the availability set when the VM is created. You can't change it after the fact, so you got to plan ahead with this stuff. So I've got an availability set. It's got 2 virtual machines in it. Each of these virtual machines has a basic web server installed, just an IIS server. And if we go to the IP address of one of those virtual machines and just browse to it via the internet. So let's come over here real quick and browse to its web address. You'll see that I've just got the basic web page, and I've noted what the name of the server is. This is web server 1's website. And if I go to the IP address for the second web server, the second virtual machine, I'll just slide back over here, web server 2. Grab its IP address. We'll see that this is now web server 2. So I've got 2 web servers available, web server 1, web server 2. They're members of an availability set. And we've got the regular supporting infrastructure elements. We've got some network interfaces, some network security groups. In these network security groups, I've simply enabled inbound HTTP. So I've added a rule to allow inbound HTTP. You see that rule right there. They've each got public IPs. The public IPs are not necessary, but I added them on so we could actually connect directly to each server if we wanted to kind of demonstrate that they're both live. But with a load balancer, the load balancer functions as the public IP. We don't need to have a dedicated public IP on each server. I've got a network and then just a couple of storage accounts. So that's what I'm beginning with. Now to add a load balancer, we're simply going to click Add. And we're going to type load balancer. Select it from the marketplace. Click Create and begin the basic properties. Now, to begin to create the load balancer, I'm going to give it a name. The type, the public or internal, simply means whether it's going to have a public IP address or this is an internal load balancer on an internal VNet that's not exposed to the public. Resource group information, click Create, and away we go. Now, the process of creating a load balancer and adding the rules does take a little bit of time. Rather than walk through all those clicks and steps, I've pre-created a load balancer using this process. And what I want to do is walk you through what I did to actually build that out. So we're going to go back, and here's the load balancer that I created just a little bit ago that I'm going to take a second and walk you through. So once it's created, there's 5 configuration settings that you can work with. Well, there's 4 that are required, and there's 1 that's optional. The optional one is inbound NAT rules, which can be used to redirect specific ports to specific locations so you can target traffic at your load balancer if you want to do that. We're not going to do that. We're just going to set up basic load balancing for web access. The first step is you want to denote your back-end pools. Now the back-end pools are the virtual machines that are behind the load balancer. And this is simply a process of selecting the VMs that you are load balancing. So you click Add, you're going to select the virtual machines by selecting the availability set that they're a member of. So we select the virtual machines, it picks up the availability set, and that is all we need to do to configure that back-end pool. Hit OK, it'll apply the rule, it takes a couple of minutes to apply. The next thing that we're going to want to do, once we've done the backend pool, is get a public IP address. And again, this is simply a matter of coming in, adding a new public IP. So we click the IP address. We can use an existing, or we create a new public IP address, static or dynamic, and we've now got the external facing address for the load balancer. The third step is to create our probes. I've created a probe for port 80 for web traffic, but we could, for example, create a probe for HTTPS or for any other port that we want to use. The probe is the item that tells us whether or not the backend server is actually online. It uses the probe to check the port. If the port doesn't respond, and you can notice here within 5 seconds, as 2 consecutive failures within 5 seconds, then we mark that particular node in the backend pool as down, and we no longer include it in load balancing. So you get some degree of fault tolerance. You have to have a probe before you can build a load balancing rule. Every load balancing rule must be associated with a corresponding probe. So I've got a probe for port 80. Just going to cancel this. And then we begin to build our rules. And so I've built a rule called web traffic. Port 80, going to port 80 on the back end. Here's the back end pool, the web servers, the probe, and I've chosen no session persistence. The session persistence is just a load balancing technique to say that, for example, if you always come from the same IP address, well, you always go to the same node. And that matters if you, for example, have session data. You want to make sure that if a user disconnects and reconnects, they go back to the same node because they've got session data there. In my case, I chose none because what I want to do is I want to be able to bounce back and forth between both nodes all the time. And so we're going to go ahead and test this load balancer. And to do that test, all we've got to do is browse to the IP address. I've not put a DNS name behind this IP address, but that doesn't matter. So we can see that if I browse to it, I get web server 1. If I do a refresh, I should get web server 2. So let's just take a separate browsing session and see where that sends us. So I just grabbed another browsing session. We'll navigate to that same IP, and we can see on that one we actually get web server 2. So there you have it, a load balancer that's just bouncing 2 different sessions between both nodes. So now that we've deployed a load balancer, what if I want to take my load distribution to the next level? And I not only want to load balance within my VNet or within my service or within my resource group, but I want to load balance across multiple Azure data centers, multiple Azure subscriptions, or multiple regions of the world. That's what Traffic Manager allows me to do. Traffic Manager allows me to create a load balancing mechanism for my load balancers. Well, let's say I've got an application deployed across 2 Azure data centers, East and West. Okay, very simple. And maybe we've also got Europe, EU. So I've got East, Europe, and I've got West. And in there, I've deployed an identical application. For the purpose of Traffic Manager, the details of the application are really irrelevant. For example, Europe, it could be a single web server connecting to a single database because I don't have that many customers. East US, it might be a scale set with 25 servers connecting to a distributed database because I have a lot of customers. And West might be a load balancer that's in front of 3 web servers. So the individual, within the region implementations kind of are irrelevant as long as what they're surfacing to the internet is basically identical. So all these are surfacing essentially an application, let's say on port 80. Traffic Manager uses DNS when a client comes in and they attempt to connect to my application. Traffic Manager uses a DNS query to determine which instance of the application is the closest physical to the user. Now, The thing to keep in mind is that it doesn't do this based on where the user is, because the user queries DNS. It does it based on where the user's configured DNS server is. So you can, if you're not careful and you don't do this well, you can find yourself in a trap. If a user, for example, is sitting in Australia and they're pointing to a DNS server in Europe, according to Traffic Manager, they're sitting in Europe. If they're in Europe using a DNS server in the US, according to Traffic Manager, they're going to be sitting in the US. So it's based on the location of the user's DNS server. Once that's determined, it redirects the user to the closest version of the application. Now, you've got a couple of options available for how you choose to configure this. Whether it's based on just sheer performance, you want a load balance, whether it's based on which applications or which sites have priority over others, you've got some configuration capability. But at the end of the day, that's the primary function of Traffic Manager. It allows you to make sure that if you have the same application distributed across multiple parts of the world or multiple subscriptions, the user gets to go to the closest one. In addition, if one of those versions or one of those implementations goes down for some reason, Traffic Manager will stop routing users to that location. You create Traffic Manager profiles the same way you create everything else. We can do these in the classic portal, or we can do them in the newer portal using Resource Manager. The catch is, if you create one in the new portal, that one's not available in the old. If you create one in the old, you're not going to see it in the new. Recommendation is, whenever possible, create things in the new portal. That's where all the new functionality is going to be. And there's some terminology changes from the old portal to the new one. Failover becomes priority, round robin becomes weighted, load balancing becomes traffic routing method. So you'll see some differences as you move from the old one to the new one. You can do this with the new portal via ARM, or you can do this straight away in PowerShell. So that's the basics of Traffic Manager. Our final module of the networking course deals with Intersite connectivity. Now, simply put, these are all the methods we can use to connect networks within Azure to other networks, and also connect from outside of Azure, such as an individual machine or such as my on-premises network, and connect that into an actual Azure network. And so we can see here, in this diagram alone, 3 of the different ways we're going to do this. We have what's called point-to-site, which is just me, my machine, VPNing to my Azure network. We have site-to-site, which is my entire network with a VPN to my Azure network. And then finally, Azure network to Azure network. Now, all of these models use a very, very similar setup methodology. I install what is called a gateway. Now, the gateway is similar to what you might have on a corporate network as a VPN device, or if you've ever set up an RAS server in Windows with VPN capability, it's conceptually very similar. I have a gateway device on each location, and in the case of a point-to-site, I just connect to the gateway device. In the case of a site-to-site, whether it's Azure site to Azure site or on-premises network to Azure site, I'm connecting the 2 gateways together for a permanent connection that anyone can then go across. So the first one is a point-to-site VPN. And this can be done, it's worth noting, to a client or to a system, depending on the configuration that you want to choose. So the first step is I create an address space. So I need a virtual subnet that's going to be assigned to incoming clients. We create the gateway. We create some certificates that are used to authenticate the gateway. This is going to create a package that I can now download and install as a user. When I download and install that, that creates a VPN entry, in either my Windows, my Linux, or my Mac system. I then launch the VPN, and it establishes the connection to my Azure site. Let's take a look at how to do that. Now we'll look at the process for going site to site. Again, this is going to be a very similar process. In the subscription, I create a VNet, and in the VNet, I create that gateway we talked about. The next step, which is a little interesting, and you know, if it's a very large network, this could get complicated, is I need to add the IP address range of my local site. So down here you can see this is 10.20.0.0 and 10.21.0.0. I register those in Azure, so Azure can now build the routing tables when the VPN is connected. If I'm trying to reach one of my on-premise servers, it knows, hey, that's over the VPN, that's how you route to get there. So I need to understand the local address space and be able to add that to Azure so Azure knows what that address space is for the purpose of building the routing tables. I then get a public IP address on my VPN device, create the gateway. Then it will give me both, you know, depending on the configuration, either a package or instructions on how to go to my corporate network and then establish the end-to-end VPN connection. Once that end-to-end VPN connection is established, I can now send traffic from my Azure VNet down to my corporate network and from my corporate network up here. This is the type of scenario that you're going to follow if, for example, you have a file server in Azure that you want to join to an on-premises domain. So I set up the file server in Azure, I establish the VPN, I can now take my file server, point it at my on-premises DNS, and join my on-premises domain. Users that are on my LAN can now browse to file shares that actually exist on a file server running in a VNet, running in a VM in Azure. So let's look at an example of that one. Okay, here we are in the Azure portal. We're going to go ahead and create some new VNets or virtual networks. So in a resource group, nice and empty, just so we can see everything nice and clear. Going to click Add and type Virtual Network. Or I just click it from the shortcut list on the bottom. Resource Manager Deployment Model, which we're traditionally going to accept. And now we begin to specify the properties of our VNet. Now, it's going to put in a lot of things, you know, as defaults right away. You don't need to accept the default. You can change pretty much whatever you want in here. I'm going to give this one a name. I'm going to call this CloudNet. And an address space. Now, the address space for the VNet has to encompass all the subnets that are going to be located on it so we can route them properly. So this is typically going to be either a 16 or higher subnet mask. So it defaulted to 172.18.0.0. That's fine. And then our subnet address range for the first subnet, we're going to modify to be 172.18.1.0/24. So now I've now got a single 24-bit mask subnet, or you know what would be traditionally not considered a Class C, but the same size as what would be a Class C subnet. And then I've got what would be a Class B size subnet as the VNet address space. Change my subnet name. I'm going to call this one subnet 1. Give it the address space, subscription, resource group, and I'm now ready to go ahead and create that virtual network. Now the thing to remember is the address spaces. We want to know those because as we add subnets and objects later on, they've got to fall within the address space of the VNet. Click Create, and the creation process is actually pretty quick. We can see here the deployment is submitted, and it's now running in the background. We'll get a notification once this subnet is created. Okay, the VNet is finished. We can now go look at the properties and begin to add some additional subnets. So to begin with, we can look at the address space. This tells us the overall address range for the VNet. This is the initial address range we created. We can actually add additional address ranges if we want. For example, this VNet maybe also covers 172.19.0.0/16. This gives me an additional set of address ranges I can use for subnets that are on this VNet. So again, we just got to make sure that when we create it, we have all possible address spaces covered in the IP address ranges of the VNets. We've got one subnet created by default, and we can go ahead and create a second subnet, which I'm going to call subnet 2. And this one, remember, we just added a new address space, 19, and this is going to be subnet 1, 172.19.1.0 on that address space. Make sure it has a unique name, and then click OK. So I've now got two subnets I can actually attach virtual machines to. And remember, Azure takes care of all the underlying routing, so we don't need to worry about things like default gateways, etc., although we can configure them if we want. We can then go configure our DNS server settings. And so this is the DNS server that's allocated to any virtual machines that have a dynamic IP address. And we can do an Azure DNS, or we can do a custom DNS if we have our own DNS server implemented, whether it's an Azure DNS server, a DNS server running in a virtual machine, or a public DNS server somewhere out on the internet. We're going to leave it on Azure DNS for now. So that's the basics of creating a subnet and a VNet in the new portal using Azure. What we're going to look at next is how we do a similar process to create an additional subnet, an additional VNet using PowerShell. So here we are in PowerShell. We're going to go ahead and create some one new virtual network. So we're going to use new Azure RM virtual network. And everything else is going to be pretty straightforward. The name of the virtual network. Let's call this one CloudNet 2. Not feeling particularly creative today. Resource group name. Location. And then the address prefix. Now, as a tip, make a habit of putting the address prefixes in either single or double quotes. Doesn't really matter which. And what that's going to do is create a new local entry. Now, it's actually going to build the configuration. This creates a new entry in the networking where you can now go begin to add subnets. So this will take just a second or two to finish, and when it does, we'll have a new virtual network. Now, the new virtual network doesn't have any subnets. We're going to do that next. So the virtual network is now created. You can see on the screen it's kind of a local representation of what that configuration is. What we're going to do next is store a copy of that configuration in a local variable, add some subnets, and then write it back to Azure. So let's do a variable. Let's call it VNet. Get Azure RM virtual network, and as you could predict, name and location. Well, resource group name. Did I make a typo? I did. CloudNet 2. There we go. So now we can look at that variable, and we can see that we've got a copy of that configuration. We're now going to go ahead and add a subnet to that virtual network. And for that, we're going to use a PowerShell command, VNet new Azure RM virtual network subnet config. So this allows us to define a subnet. Name of the subnet. Let's call this one subnet 1, and the prefix. Remember, this has to be within the scope of the IP address range defined for the VNet. So we'll do .18.1.0/24. Did this command wrong. Apologies for that. The final variation is, well, what if I want to connect two different VNets in Azure so they can talk to each other? This is done in an almost identical fashion to doing a site to VNet connection. I'm going to establish a VPN gateway in one VNet, establish a VPN gateway in another VNet, and simply connect the two together. So I treat each VNet essentially as an on-premise site. Treat the other VNet, sorry, well, with each I treat the other VNet as an on-premise site, connect the two VPN endpoints, and now the two VNets can actually talk to each other. And so this is how you connect two networks together that, for example, are in different Azure regions, different Azure subscriptions, or just on different VNets. So the basic steps: create the virtual networks, get the public IP and gateway configuration, create the gateway, and then repeat the process on the second network, and then connect the two VPN gateways. So it sounds like a fairly straightforward process. It is, and we're going to go ahead and do it. Let's look at the process now for deploying a site-to-site VPN between two VNets in different Azure resource groups, and in fact in different Azure regions. So what I'm going to begin with is two resource groups. I have S2S East and S2S West, and they are located in the East and the West US data centers accordingly. Within each of these resource groups, I have a simple VM, and that VM is on a network. And if we look at the network, you can see we've got just a couple of subnets. Now, we're not going to look at both resource groups, but they are configured essentially the same. There's no overlapping IP address schemes. There's no overlapping subnets. There's a simple resource group with a VNet with two subnets and a virtual machine. And the interesting thing is that those two virtual machines cannot ping. They cannot speak to each other. So here I'm pinging from east to west, and here I'm pinging from west to east. And we'll see that those pings are failing. Now the reason they're failing is because those two VNets are not in fact connected. So I'll let these time out. Take a quick look at the IP so you can in fact see that I am pinging the real IP addresses. So there's 12.204, which is what I was pinging over here. And this guy is 12.4204, and so this one's actually stored in the West US, and I was pinging on the east side. So what I'm going to do is start a ping running. Just let it run here in the background, and then we're going to go behind the scenes and actually establish a VPN connection. And we'll see that once that VPN connection is established, that connectivity between those two different VNets is also going to be established. Now, to set up site-to-site, or I guess VNet-to-VNet VPN connectivity, you have to deploy a virtual network gateway. Now, I've already deployed my virtual network gateways, and the reason I've done this is because, well, they take 45 minutes minimum to actually deploy. When you're deploying a virtual network gateway, the process, and we'll just kind of go through this and click cancel, is actually pretty simple. Add, and then in the marketplace, we're going to look for a virtual network gateway. Select that, hit create, and it's going to want just the bare minimum of configuration. A name, the virtual network it's on. Now if we're doing a VNet to VNet, we need two of these, one in each VNet. So the name of the virtual network it's on, and then it needs a public IP address. So you just assign it or create a public IP address. And then these types of VPNs are route-based VPNs. So everything else remains at default. Name, virtual network, and then we give it a public IP address. Once they're deployed, there's really very little you have to do to configure them. It's actually quite simple. It's deployed. We're now simply going to configure a connection. And we're going to do two connections. We're going to do one each way, one from east to west and one from west to east. I'm going to begin in the east and add a connection which connects me to the west. Select my local gateway and then select the opposing gateway that I'm going to connect to, and give it a pre-shared connection key. I'll then go to the west and create a connection back to the east. Select the gateway, connections, add to east. Select the east gateway, You can see the resource group it's in, and put in my pre-shared key. Now, it'll take just a couple of minutes for those to be created, and once they're created, it will go ahead and establish the connection to enable those packets to go through. Now, if I drop back to my 2 ping sessions that are going on here, in not too long, those connections are actually going to be established, and those pings are going to begin being routed. Now, usually, so there's the first one going through. The second one should appear in just a second. There it is. So those VNet to VNet connections are established. It's a pre-shared key-based VPN, and we can see that those 2 VMs on separate VNets in separate resource groups in separate data centers now have underlying network connectivity. So the final way that we can connect our sites together within Azure is through something called ExpressRoute. Now, ExpressRoute is reserved for those scenarios where you want an extremely high performance, high volume connection to Azure, or you want an incredibly distributed network that includes Azure. Here's the difference between ExpressRoute and the other implementations that we've talked about. With a VPN method, I have an Azure subscription in VNet, and I have sites that I want to connect to Azure. Well, to do that, I simply connect a VPN connection. So I use a Azure to site-to-site VPN connection. Now, if these other 2 sites want to reach my Azure subscription, I can only have one VPN endpoint in a VNet. So now I've got to look at going through my central site up into Azure. And you can see how, if these sites are very distributed, this could create a potential issue. Maybe this site here is in, these are on different continents. So I've got to cross to a new location, back up into Azure. In addition, this is VPN over the public internet. So by definition, it's going to be a little on the slow side. Even with a really good connection, you're still limited to somewhere around 100 meg per second, in the best possible conditions. The reality is it's probably going to be a lot slower than that. So while it's great for management type connectivity or small amounts of data, this is not desirable if, this is how you get at your file servers. So if I've got 2 file servers up here, and I want to browse and download files, and I'm a user over here, this is not the most desirable method of getting access to those files. That's where ExpressRoute comes in. ExpressRoute goes back kind of almost to the days before VPN, where you could create private networks across the public internet cabling system, essentially. So I have Azure, and I have my different sites. I can create a network within my ISP and within Azure that's a private network that encompasses all 4 of these locations, allowing direct routing between any location to and from Azure and to and from each individual location at speeds upwards of 10 gigabit per second. Now, it's important to keep in mind that this is obviously not for everybody, and obviously there's a lot of cost involved. Also, not every ISP or every possible location or configuration supports this. But it extends the notion of an on-premise network using layer 3 switching connectivity over dedicated private connections to give you what is essentially a direct link to your Azure VNet that doesn't go over the public internet and doesn't go over VPN. So if you're concerned about, for example, security, you don't want your data within a VPN routed over the public internet with everyone else's traffic, ExpressRoute ensures that your connections are truly private. There's no one else's data on those connections but your own. On the Microsoft side, there are 2 connections with edge routers within each Microsoft region for the best reliability. They, as I mentioned, they do not go over the public internet, and BGP is used to handle all the routing. So with that, that's a pretty good overview of how you manage and implement networks within Windows Azure. Everything from creating VNets and subnets all the way to the highest, best possible performance options of ExpressRoute.